So VLAN, virtual LAN. So if you know about a LAN, then you shouldn't have a problem dealing with VLAN. What are these virtual LANs? And to understand this properly, let's get to the objectives. I mean, what are we going to cover in this particular topic? So we will explain how network protocols enable devices to access both local and remote network resources. So we do an overview of the VLANs and explain the purpose of the VLANs in a network, especially a switched network. That's a network that uses switches. We'll explain how the switch forwards frames based on VLAN configurations in a multi-switched environment. All right. We'll also configure VLANs, and I'll take you through a very good demonstrations on how to create and configure these VLANs based on some requirements. All right. And then we'll talk about something called a track. You might have heard about this, or maybe you didn't. So we will talk about a track, and we configure the protocol that regulates tracks. It's called the DTP, Dynamic Trunking Protocol. So let's start by get an overview of what VLANs are. Now, let me take you through a very brief illustration here on how companies normally use VLANs. So this building is a company that has rented this building, and they're using the first floor, they use the second floor, and they use the third floor here. Okay. And this company has 3 departments. They have the sales department. Maybe this is Safaricom, or this is any other telecommunications company. So they have their own IT department. It's sort of the IT issues. They have the human resource, HR department, and they have the sales department. Now, since they have their staff on 3rd floor, 2nd floor, and 1st floor, each and every floor have their own IT department, HR, and sales. So IT, HR, sales on the 1st floor, IT, HR, and sales on the 2nd floor, IT, HR, and sales on the 3rd floor. All right. And you can see we have computers within each and every floor. We have computers for each and every department. So each floor have their own switch here. 1st, 2nd, and 3rd floors, they have their own switches, and they have their own computers, their own end devices here. Now, listen to this. We are going to break some protocols, what I have taught you guys in the previous chapter. We are going to have a situation whereby in the 1st floor, we have computers for IT guys, we have computers for human resource guys, and we have computers for the sales people here. Okay. The problem is one, when a computer on the IT department sends a message to the switch, all right, even though all the 6 PCs are all connected to the switch, this switch here on the 1st floor, when one of the computers on the IT office connected to this switch sends a message to the switch, this time around, something funny is going to happen. The switch is not going to broadcast that message to all the computers connected to it. Why is it so? It is because the switch is no longer having only one VLAN. VLAN. The switch is now having multiple VLANs. As a matter of fact, the switches is having a VLAN created called VLAN 2 for people in IT department. They are in their own VLAN. They are actually in their own LAN, in their own network. People in the HR are put on VLAN number 3, all right? And they are in their own network as well. And people in the sales department are also put in their own VLAN 4, all right? And they are in their own network. And that's why a computer within the IT sends a message to the switch, cannot broadcast that message to all the computers connected to it. As a matter of fact, that message can only reach people within the same VLAN. Only people in VLAN 2 will receive the message. When a computer in VLAN 3 sends a message, only people in VLAN 3 will receive the message. When a computer in VLAN 4 sends a message, only people in VLAN 4 will receive that message. Listen to this. In the second floor, remember, we also have computers on VLAN 2 for IT. And in the third floor, we also have computers on VLAN 2 IT, which therefore means even though we have computers in IT, some connected to the switch on third floor, some connected to the switch on the second floor, and some connected to the switch on the first floor, wherever a PC in any of the floors sends a message to any of the switches, the switches will receive that message, but that message will only be sent to PCs on the same VLAN. Only PCs on the same VLAN will receive the message regardless of the floor and regardless of the switch where they are. Very important. So the only time when PCs on VLAN 4 can receive a message, a broadcast message, it is when the PCs, one of the PCs of that VLAN will be able to send a message. So I'm introducing a very important concept here, which I need you guys to understand. All right. So why do we create VLANs? When we create a VLAN, regardless of which floor, so long as the switches are connected to each other, only switches on the same, only PCs on the same VLAN will always hear the message. Okay. And I need to just go back a little bit and explain something to you guys. Let's look at switches, a network with VLANs, a network that is that's not having any VLANs, network without VLANs. And I'm gonna play an animation here, and you guys are gonna see what normally happens. So this is a network without VLANs. If the networks are not having like multiple VLANs, it means switch S2, switch S1, and switch S3, all of them have the same VLAN, which is VLAN 1, the default VLAN. And let's see what happens. So PC1 sends a message to S2. That was so fast. Let me just restart it again. So PC1 sends a message to switch S2. Switch S2 is going to broadcast it to S2, to PC2, PC3, and to S1. Okay? S1 receives it, it goes to S3. S3 receives it, it goes to PC4, PC5, and PC6. Remember, the message can never go back to where it came from. S2 receives from PC1, S2 broadcasts to everyone else here, except it cannot go back to PC1. S1 receives from S2, S1 cannot send it back to S2, it can only go to the other active interfaces. S3 receives the message, it can go to PC4, PC5, and PC6. It can never go back to S1. A switch can never send back a message where it was originated. So look at what happens here. Again, a switches that are on one VLAN. We don't have multiple VLANs here. So when a switch receives a message, it is broadcasted to everyone. It is broadcasted to everyone. Now, I now want to assign these PCs on different VLANs. And let's look at the same thing here. What's going to happen? So this time around, PC1 and PC2 are on different VLANs. PC1 is on VLAN 10, and we have given it a name, faculty. PC2 is on VLAN 20, and we have given it a name, student. And PC4 is on VLAN 10 as well, and we've given it the name, faculty. PC5 is on VLAN 20, and we have given the name, student. And so PC2 and PC5 are on the same VLAN. PC1 and PC4 are on the same VLAN, but PC1 and PC2 are on different VLANs. So let's see what happens. let's see what happens when PC1 sends a message. All right. So it goes to the switches, but it's only heard by PC4 to S1 to S3 to PC4. Okay. From PC1 to S2 to S1 to S3 to PC4. This is now a network that is having VLANs. A message from one VLAN can never go to another VLAN. We will later on learn that how can we make PCs on different VLANs to be able to communicate. For example, for PC1 and PC2 to communicate, even though they are connected to the same switch S2, for them to communicate, we need a layer 3 device because a VLAN is a layer 2 protocol. So remember, to communicate normally from one network to another network, we always need a layer 3 device, a router, or a layer 3 switch, or a multi-layered switch. All right. Having talked about that, I now want us to continue with our discussion here and move on with our illustrations. So using VLANs, it normally segments various groups of devices. For example, you can separate one department from another department by using VLANs. Very important. Let's give an example of a university, for example. A university normally has students. It has the IT department. It has the HR department. It has the examination department, the senior management department. All right. So sometimes the university finds it very necessary to separate the students from either finance department or the accounts department or from the examination department, because students have always been very knowledgeable by use of some free tools, and they can find very nefarious and very funny ways of accessing the finance network. And research done before has shown that students can actually hack into the examination database, and they can, fill in their own marks for the courses they failed in. It has been reported before. The students have been able to fill in and clear their fee balances without paying any money at the bank. And so institutions have found it very necessary to separate the students' network from other departments by using what's called VLANs. And that means the use of VLANs is actually a security mechanism for our network. Of course, VLANs will also help us to have small broadcast domain. What do I mean by that? Small broadcast domain in such a manner that when a PC in one VLAN sends a broadcast message, the message cannot go to all the PCs in the network. It will only go to the specific PCs on the same VLAN. So that is going to make us to have very small broadcast domain. The message does not go to everyone. It only goes to specific people within the network. All right. And so as benefits of using VLANs, small broadcast domain, we have said it, we have mentioned something about security. Of course, it improves efficiency because you can group devices according to some requirements, okay? Like students, faculty, finance, HR. Of course, it reduces cost because you can separate ordinarily without VLANs. To separate two departments, you will need to buy a router. But this time around, you don't need to buy a router. The existing switches that you have, you can just learn how to create VLANs, which we're going to be learning today. And that's it. That's enough for you to do. And of course, because of the small broadcast domains, it improves the performance, And because as an IT guy, you can group governments according to similar department, and that is simpler management. That is going to cause simple management. All right. Now, we're going to talk about the types of VLANs. And remember, initially, we only have one VLAN, which is VLAN 1. And it plays the role of all the types of VLANs that we are going to talk about today. Now, the default VLAN, which is VLAN 1, it is always by default, it is the default VLAN. It is the native VLAN. It is also the management VLAN, and you can't delete it. It cannot be deleted. It cannot be renamed, and it's just there. Now, looking at this diagram here, most Cisco switches will always have the default VLAN. You can see here, VLAN number 1, and the name is default. That's the name. Of course, by default, all the ports that the switch has are always found under VLAN 1. Fast Ethernet or FA0/1, all the way to Fast Ethernet 0/24 here. Gigabit Ethernet 0/1 and G0/2. All the ports are always under one VLAN, and that's why all the active ports will always hear the message when it is broadcasted. Okay. When you create VLANs and assign some of these ports to those VLANs, now that is the point when the PCs can never communicate back, and I will show you that. And I've already demonstrated to you that PCs on different VLANs cannot communicate among themselves. Now, so by default, the first type of VLAN is called the data VLAN, and VLAN 1 is always the default data VLAN. This is just used for carrying our data traffic, emails, web traffic, so on and so forth. We have a VLAN called native VLAN, which is only used within the trunks, and I will talk to you about what a trunk is. Management VLAN, this is used for management of your device, either through SSH or Telnet. You can be able to manage your devices remotely. Okay, and VLAN 1 is always the default management VLAN as well. Of course, we have the voice VLAN. This is for carrying voice traffic when you're using the voice over IP gadgets there. We have a separate VLAN which will be used to carry the voice VLAN, and it will be having quality of service and assured bandwidth for all these, for all the voice traffic. Now, what I want us to do right now is I've already talked about all these ones here, and we are going to talk about trunks. And before I talk about a trunk, let me just talk about looking at this diagram here. We have PC1, we have PC2, PC3. PC1 is on VLAN 10, PC2 is on VLAN 20, and PC3 on VLAN 30. PC4 is on VLAN 10, PC5 VLAN 20, and PC6 is on VLAN 30, which means PC3 and PC6, same VLAN. PC2 and PC5, same VLAN. PC1 and PC4, same VLAN. So when PC1 sends a message to this network or to switch S2, only PC4 will hear the message. PC2, PC3, PC5, and 6 are not going to hear that message. All right. And so you realize that the link connecting the switches to the PCs, okay, they can only carry traffic from each PC. That PC will always be on a specific VLAN. That means that these ports that are connected to the PCs, we call them access ports. Access ports because they'll be carrying the data traffic from the PCs. Now, this F011 here, which is connected to PC1, it can only carry traffic from VLAN 10. F018 connected to PC2 can carry traffic for VLAN 20. F06 can only carry traffic from VLAN 30. What about F01, which connects switch S2 to S1? It's a very special link. Why is it special? Because it is going to carry traffic from all the three VLANs. VLAN 10, VLAN 20, VLAN 30. All this traffic will be able to go through the link between S1 and S2, and the link between S1 and S3. All right. So this link, which can carry traffic from more than one VLAN, is called a trunk. We call it a trunk. Okay. Now, a trunk can carry traffic from all the VLANs from one switch to another switch. Sometimes trunks can also carry traffic from a switch to a router, and we will talk about that soon enough. Now, moving forward, these are the things we were actually talking about. We saw this animation priorly, and of course, normally VLANs will carry the frames will carry a small tag for the VLANs, and that tag will be telling the switch that the traffic you're carrying here is from a specific VLAN, and it has a VLAN ID. Okay, but most importantly, the header will always carry some 4 bytes, for the VLAN, and of course, just signifying that it is carrying some VLAN traffic. Now, of course, whether it is voice VLAN or not, it will also be present on that particular network. And we did talk about things like COS, which is class of service. Basically, these ones are for quality of service. And this is because this VLAN will be carrying traffic that is voice traffic, which is supposed to be given some priority on the network. Now, I want to talk about that now, how to create VLANs. And that is something that is very, very important for me. How do we create these VLANs? Now, number one thing that I want you guys to note is that every switch, including the one that I'm going to display to you, I'm going to open my packet tracer to show you this that you're seeing here. We need to learn about the different 2 categories of VLANs. The first category is called the normal range VLANs. Normal range VLANs. So the normal range VLANs start from VLAN number 1, which is the default, all the way to VLAN 1005. VLAN 1 to 1005 are called normal range VLANs. Okay, these are the ones that are used in our normal LAN networks. And the normal range VLANs, since they range from number 1 to 1005, from 1002 to 1005 are always there by default, and these ones are reserved for some legacy VLANs. These ones are reserved, and you'll always see them in a switch: 1001, 1002, 1003, 1004, and 1005. And so that is from number 2, 3, 1002, 3, 4, 5. Those are 4 VLANs plus number 1, the default VLAN. So a total of 5 VLANs are always found in the switch by default. Okay, so 5 VLANs, you cannot delete them. They are found in the switch. Any new switch will always find those 5. Number 1, number 1002, 1003, 1004, and 1005. These VLANs are always stored in a file called the VLAN.dat. All right, the VLAN.dat, and you can see that here, the VLAN.dat file, this file here, which is stored in the flash memory. We have then from 1006 are now called extended range VLANs. And they start from 1006 all the way to 40,095. 40,095. These ones are extended range VLANs. These ones are used by service providers. They're used by service providers, and they're normally found within the running configurations. Okay, they support very few VLAN features, and they require VTP to work. VTP means VLAN trunking protocol. You will meet VTP in the later chapters of your studies. Now, I wanted to show you guys how to create VLAN. Before I come back there, let's look at my packet tracer here. And I'm gonna grab a switch here, maybe 2960 series switch. Okay, I'm gonna zoom it here and all right. This is my switch. Now this is a 2960 series switch with 26 ports. And let me just go to the command prompt here. And I don't know whether you can see my command prompt. I could increase the font if you want. For the font and give it the highest is 20. I think that is the highest that I can take it to. All right. So this is my switch. I could just increase the size here. And now I want to let's view the VLAN table. So I would say enable. I would say configure terminal, enter, and I will say I would say show VLAN brief. Show VLAN brief. You should be able to see that here, that this is my switch. Before I create any VLAN, it is having the VLAN 1 here by default, and the name is default. It has this 4 here from 1002 to 1005 and number 1. So number 1, 1002, 1003, 1004, and 1005 are found in the switch by default. By default, all the ports on this my switch are contained within VLAN 1. Yeah. Now, let me create a VLAN, and you are going to see how it is going to be present here. All right. So creating a VLAN is very easy. Let's say I want to create VLAN 2. I just need to say VLAN. Then I say 2. Then I press enter. Then I must give it a name student. And I press enter. So if I say do show VLAN brief and I press enter, you can see my VLAN number 2 will come here. You can see VLAN 2 and the name is student. Okay. I can create more VLANs. I could say VLAN, and I didn't tell you something. If 1 is already present, it means we can create number 2 all the way to 1001. So I could create VLAN 1001, enter, name, extreme. Okay, there. And I say do show VLAN, and you can see 1001, it's here, extreme. All right. I could create VLAN number 500. VLAN 500, enter, name, punch. Okay. And I could just say do show VLANs again, and you can see my VLAN 500 is here. So creating VLANs is very easy. Just say VLAN, put the number, and then you name it. Say name VLAN, this one. Now, how can you remove some of these ports from, because up to now, we still have all the ports are found under just one single VLAN. Now, for example, I want to take port number 1, remove it from here, from VLAN 1, and assign it to port 500. See that? So I will say interface F0/1, that's F1, enter. Then I must make that port to be in access mode by saying switch port mode access switch port mode access, enter. Put the port in access, switch in access mode. Then you say switch port here, switch port access VLAN 500. See that? Switch port mode access on that interface, put it in access mode, and then assign that port to that VLAN. Swing the VLAN to that port, switch port access VLAN 500. Then I press enter. This time round, when I say do show VLAN brief, look at what happens. VLAN, port number 1 is no longer here. Port number 1 has been brought down here. Under which VLAN? Under VLAN 500. Port number 1 is now brought under VLAN 500. And I could take several ports. For example, this time round, I want to take F022 to 24. All right. So you say to take more than one interface, I need to use the range command. Interface range F0/22 to 24, G0/2. All right. If the ports are not following each other, use a comma to separate them using the range command. So press enter. Then I say switch port mode access, enter. Then I say switch port access VLAN. Let me take which VLAN? Let me take VLAN 2. Enter. All right. So if I say do show VLAN brief, look at this. This time round, I have taken to VLAN 2, I've assigned it to port F22, 23, 24, and G02. They are no longer found within the VLAN 1. So that's how we assign ports to VLANs, okay? And right now, when a message is sent from F01, it will never go to any of these ports over here because these ports are now assigned to different VLANs, All right. Assuming I can, be able to minimize that. And let's say I drop another switch here. All right. And I'm going to pick a cable here and I'm going to join these two switches. Let me take a crossover cable on a G01 to G01, this other side. All right. And I give some PCs over here, some end devices. I'm going to pick just laptops, a few of them here. So I have 3 of the laptops here. All right. And I'm going to bring up some more laptops here. All right. So more laptops here. And more laptops here. And pick up some crossover cables. And I connect here to the first Ethernet port. Put this on F01. This is going to be put on maybe F015. And I put this on maybe F024. All right. And do the same here. F01. F015. And F024. Put it here. All right. Now, so we have these ones. These ones will be our access ports here. All right. Because they are connected to the PCs. And the link between the two switches will be a trunk port. The link between the switches will be a trunk port. And you're going to learn by, we'll create another VLAN called, and we give it the name trunk. So I now want to teach you about a trunk because a trunk carries traffic from one switch to another switch. So if this was G01, I'll get into this switch and I will say, let me create the VLANs first. Just say exit here. I will say VLAN 700. Let me say 900, for example. And I say name is trunk. Name sorry, not name trunk, name native. All right. And I go to this other VLAN switch here and do EN. I do configure terminal and I create also, because of time, VLANs 900. Name is native. Name is native. All right. Now, since we know that we have created some VLANs here, we now want to configure the trunk length between the two switches, which is found on interface G01. So I'll say interface G0/1, which is the trunk. This time round, we don't say switch port mode access. This time round, we say switch port mode trunk because it's connecting the two switches. Say switch port mode trunk. Enter. Then you say switch port trunk native VLAN 900. Only the 900 VLAN is assigned to the trunk port. Switch port trunk native VLAN 900. Okay. Then, but we need to allow all the VLANs we had created. So we say switch port. Press the tabs key. You keep on seeing some of these messages pop up. Switch port trunk allowed VLAN. Switch port trunk allowed VLAN 2, 500, the other one was what? 1001, probably 900. All right. And we need to do the same on both switches. All right. Then we need to go to this other switch here. And we also say, we go to the same interface, which was interface G0/1. We say switch port mode trunk. Enter. Switch port trunk native VLAN 900. Enter. Switch port trunk allowed VLAN 2, 500, 1001, and the other one was 900. It's okay. So what are we doing? We're allowing all the VLANs. First, we make this a trunk link by configuring the native VLAN. Then we make it to be a trunk, assign it to the native VLAN, and then we allow all the VLANs so that traffic from this PC, let's say it's on VLAN 1, it can easily move here, this PC here. Traffic from this PC can be carried through the same trunk, and traffic from this PC on a different VLAN can also be carried through the same trunk. This is very, very interesting. All right. Now, this was just for data. This is for data traffic. Traffic from this laptop will be, of course, data traffic. Now, how do we configure voice traffic when you have a voice over IP phone in your network? I'm going to take us back to notes here, and I want us to look at something here very important. And I'm going to repeat what I have actually been talking about, and just be attentive, and you're gonna get to know what I'm talking about. So let's look at this syntax checker. Complete the following steps to create a data VLAN. Complete these steps to create a data VLAN. So we are told, enter the global configuration mode. Configure terminal. Configure terminal. Then you're told create VLAN 20. We say VLAN 20. Enter. Name the VLAN student. Say name student. Enter. When you're told to return to privilege exec, of course, we're going to exit. We need to do end. Okay. So when you do end, then we are told to display the brief VLAN information, which means we need to say show VLAN brief, the brief VLAN information. And you're going to see that the VLANs we have already created. We created VLAN 20 and it is active, but we have not assigned it any ports here yet. All right, let's move on. You're told to enter the global configuration mode again. We say configure terminal. Okay. Create VLAN 150. We say VLAN 150. Enter. Name it voice. Say name, voice, enter. Then we need to return to the global configuration mode. We're gonna just exit here. Now, we now need to follow these steps to assign the ports to different VLANs here. Okay. So we are told to enter the interface configuration mode using FA0/18. Okay. So we're going to say here, we're going to say here, okay. We're going to say interface FA0/18 to get into that interface. Then we're going to say configure the port as an access port. We say switch port mode access, enter. Then you say that data VLAN 20 to the port. We say switch port access VLAN 20, VLAN 20, correct. And then we need to enable QoS settings with the MLS QoS trust. Now, listen to this. We have set this port to be in access mode. Okay. Remember, it is the same port that is going to carry, if you look here very keenly, for the voice traffic, I don't know whether you'll be able to see it, is, yeah, right here. We are having this port here carrying traffic for both PC and the voice over IP, phone. Now, in most cases, in every network, if you go to the secretary's office or, most offices, you'll only see only one cable coming into the office. But that cable, when it comes into the office, normally it doesn't go into the computer directly. It first goes into the IP voice over IP phone, and then there's a connection that is made from the voice over IP phone to the PC. And so what happens normally is that this F018 here is going to carry both voice traffic that is going to the phone and data traffic that's going to the PC5. And that's what we are currently configuring. We configure this port to accept both voice traffic for the phone and data traffic, and never to mix both. All right. So let's see that here. Correct. So we have already completed the configuration for data traffic. Put it in access mode, then assign it to the data VLAN. Then we need to enable the same port for quality of service. We say MLS QoS trust COS. MLS QoS trust COS. Then we need to assign it the VLAN 150, which is for the voice. So we say switch port voice VLAN 150. Switch port voice VLAN 150. Then we need to return to the privilege exec mode. We do an end there, and we display the brief VLAN information. Okay. Now, we say show VLAN brief. And if you do show VLAN brief, what you're going to be seeing here is that we do have two VLANs, 150, which is voice, VLAN 20, which is student. And now F018 has been assigned to a data VLAN 20 and also to a voice VLAN 150. This is the only time you can assign the same port different VLANs. Otherwise, you cannot assign the same port to different data VLANs. All right. Now, you realize that we don't have F018 here. From 17, we go to 19. That means that port has been removed from the default VLAN 1 down here. Okay. Now we want to learn how can we delete VLANs. How can we delete VLANs? And we verify that the deleted VLAN on that particular port. Okay. So we're gonna need to enter the global configuration mode. We say configure terminal, enter. Then we try to enter the interface configuration mode using F018. So say interface F0/18. Okay, enter. Then we need to remove the data VLAN from the port. We say no switch port access VLAN. No switch port access VLAN. Remember, we will say switch port access VLAN 20. So yes, insert the word no and then remove the VLAN value, the VLAN ID. No switch port access VLAN, and that's how we have removed the VLAN 20 from it. We have already removed the data VLAN. Then we are told to use the do form of the show command to display the brief VLAN information. So we say do show VLAN brief. When I say do show VLAN brief, you can see that the data VLAN 20 is no longer having F018 here. And we realize that it has gone back here, but we are still using it partly for the voice VLAN, All right. Then we are told we're going to need to reassign it somewhere else. So we're told to enter the interface mode for F011. We say interface FA0/11. We need to assign it to VLAN 20. We must first say switch. They're not going to give you that instruction here. They are assuming you have already learned what you need to first do. If I just say switch port access VLAN 20, because I have been told to assign VLAN 20 to the port without putting it in access mode, it's going to be wrong. Let's see what happens here. It tells me you must enter the exact and full command. So the system expects you to know that before you assign any port to a VLAN, you must first put it in access mode. So you say switch port mode access. Then you say switch port access VLAN 20 here, and that is accepted. Then you're going to need to return to the privilege exec mode using the command end. All right. So that if you now display the brief VLAN information, say show VLAN brief, we can now see that VLAN 20 has been reassigned to a new port F011, which is no longer here. From 10, we go to 12. All right. And that is very important for VLAN configuration. Then you're told to display the VLAN information specifically for the student VLAN. We say show VLAN name student. Okay, you can, by the way, display VLANs by names or even by number. So VLAN name student, and we can be able to see the student VLAN was VLAN 20, and it is assigned to F011 and 18 there. Now, show display VLAN summary information for the VLANs. We say show VLAN summary, show VLAN summary, and that's going to give you a total of the number of VLANs available here. You realize we only created 2 VLANs, but we are seeing 7. We are seeing 7 here because The switch by default has 5 VLANs. Remember VLAN, the default VLAN 1, 1002, 1003, 1004, and 1005. So those are 4 by default. So plus the 2 we have created 20 and 150, they're now 7. Display the switch port information of F011 for the interface in designation. Say show interface FA0/11, then you say switch port. So that displays the VLAN information about that particular interface. The switch port is enabled, the mode is static access, the operation mode is down, encapsulation, native, and all that. So many stuff. Of course, it's on VLAN 20, which is called student, and the native is the default VLAN, which is VLAN 1. So this is definitely something that you guys would like to practice more. I'm gonna give you some work so that you can be able to, basically to practice and be able to also learn how to create VLANs. Okay. Now, just to continue with our learning here, we've already seen how to create all these VLANs, names, and put them in access mode. And we've learned how to create the voice VLAN and data VLAN as well. And we've learned how to display using all these commands, show VLAN names, student summary. All those we have actually done them. We've seen how to delete VLANs, by the way. You use form. If you just say no VLAN 20, and let me just demonstrate that here. Right, let me bring up my switch here. If I go to this switch and I say show VLAN brief, you realize that I was having how many VLANs? VLAN 2 created 500 and 900. If I want to delete VLAN 900, I'll just say no VLAN 900. If I say no VLAN 900 and I say do show VLAN brief, we can't see VLAN 900 in my list anymore. Okay, so the command no VLAN 20, no VLAN 900 is normally used to delete VLANs. Now, since the VLANs are always created in a VLAN file called VLAN.dat, we can actually erase the whole database to remove all the VLANs. And we need to go to the privilege exec command to say delete VLAN.dat. Delete VLAN.dat, and you say, let me just say copy running config setup config, and now I want to say just delete. I was just saving them in the setup configuration file if I can delete them. So delete VLAN.dat. That is the that means VLAN database. So press enter, and you can see it tells me delete that file name VLAN.dat. You enter, and you confirm by entering the third time, and that delete, it has been deleted, and you can see it was in the flash memory there. And now we need to reload this switch, and the switch is loading. Because it is in a simulated environment, it won't take long. You can see that my switch is restarting, and it's already here. And if you say show VLAN brief, I needed to erase the startup configuration file. I know it. So you needed, once you say delete VLAN.dat, then you say erase startup. I forgot that. Erase startup -config to remove everything, and I press enter twice. Okay. I was actually do that before reloading the switch. I was supposed to erase the startup config, erase startup -config, then I reload my switch. Let's see if the VLANs are going to be there. I am restarting the switch. That's what the operating system is just restarting. And check on this, show VLAN brief. And the switches are they're currently still here. Why are they still here? They're still here because I've not done so on the other switch, the other side. Once I do that, they are being copied by something called VTP, which is currently on here. Okay. Once I do that, you can see they are no longer having any port assigned to them. Okay. But they've actually gone. So if we do both on the other switch, just for the sake of time, they normally, all of them would normally just go. Normally just go. Now, one thing I would also like to note is this, that when you want to delete the port, and the ports were originally assigned, you want to delete a VLAN, and the VLAN was originally assigned to a particular port. It is best practice to normally remove that particular port on that VLAN. You can see some messages popping up here for native vSmart. It is always important to remove the port from the VLAN before you delete those VLANs. Otherwise, your ports might remain hanging at some point, and that is not something you want to deal with. That is not something you always want to deal with. Okay, but we will come to management of the VLANs at a later class, and we'll be able to see how to manage these VLANs. Otherwise, for today, we wanted to see how to manage, how to create and identify and name a VLAN so that we can always manage things like this. And along your line of duty, you're going to have problems like this. You're going to have problems like this. The most important thing is how do you work around these stubborn features within your switch, okay? And that is something very important for troubleshooting. And how do you manage some of these slog messages that you're actually getting there through CDP, through the Cisco Discovery? And this message will keep on popping up. It will keep on coming up anyway. Now, we talked about the trunk. We did talk about the trunk, and now I wanted us to briefly talk about the trunk. Of course, we have already configured the trunk, say interface, switchport mode trunk, switchport trunk, native VLAN something, and then switchport trunk allowed, and you put the VLANs in a list. Now, we have an example here, switchport mode trunk, switchport trunk, native VLAN 99, switchport trunk, allowed VLAN, all these we are able to do, separate them with commas. What happens when, of course, there are commands like show interfaces F01 switch port that will display both switch information, VLAN information, and the trunk information. And we also talked about, of course, you can also, just like you can remove a VLAN from a port by saying no switch port access VLAN, you can also say no switch port trunk allowed VLAN and no switch port trunk native VLAN. These are the commands from removing those settings on your port. So the word no is a very, very powerful command within our devices. It negates anything that you have done or configured within your device. I want to talk about this called DTP, Dynamic Trunking Protocol. This is the protocol that helps the switch to negotiate to form a trunk. It helps the switch to negotiate to form a trunk. All right. And so it is important that we understand how does the switch form the trunk. Remember, the trunk is always found between two switches to enable the link between the switches to carry traffic from more than one VLAN to the other end of the switch. And so by default, we have different types of switches, 2960, 2950. And these switches, their default mode is always the dynamic auto. Okay. So remember, we have talked about two modes today, switchport mode access and switchport access, switchport mode access and switchport mode trunk. We also do have switchport mode dynamic auto and switchport mode dynamic desirable. And we are going to talk about those today as well. We also have, of course, one called switchport mode no negotiate. Switchport no negotiate. The switchport no negotiate command and you can see it here. Switch port non-negotiate normally is used to configure between two switches to stop the formation of the trunk through negotiation, to stop the negotiation to form the trunk through DTP, through the dynamic trunking protocol. Now we have 4 modes here. 4 modes of the switch port. We can say switch port mode access. We have used that today to put the port in access mode. We have say switch port mode trunk to put the port in a trunk mode. But we have not met these ones here. Switch port mode dynamic auto and switch port mode dynamic desirable. By default, all ports are always in this form. By default, every switch is in the mode of switch port mode dynamic auto. So we always either change it to access to form an access on the links connecting to our PC, and it's so switch port mode dynamic, switch port mode trunk on the links connected to switches. We can also form the trunk using this other method here, dynamic desirable. And that's why we do have this table here. This table helps in the formation of the trunks, whereby this is one side, this row here is one side of the switch, and this other is the other side of the switch. So you have two switches, linking them together. If you put one side to be dynamic auto, which is always there, default, and the other side is dynamic auto, it will be in access mode. Now, dynamic desirable with dynamic auto will form a trunk. Dynamic auto with the trunk will form a trunk. Dynamic auto with access will form an access port. Now, dynamic desirable with dynamic auto will form a trunk. Dynamic desirable with the dynamic desirable form a trunk. Dynamic desirable with the trunk will form a trunk, and dynamic desirable with access will form access. If one side is trunk and the other side is dynamic auto, they form a trunk. One side is trunk, the other side is dynamic desirable, form a trunk. One side is a trunk and the other side of the link is a trunk, they form a trunk. One side is a trunk and the other side is access. It forms something that is undefined. We call it has very limited connect. Actually, it will prevent the port from communicating because the port is confused. One side is access, the other side is all the others. They're going to form an access port except the trunk link that will form some limited connectivity. So you are going to use switch port mode dynamic access, switch port mode access a lot and switch port mode trunk a lot. During your industrial certification exam, the global exam, the most common command I've seen is always trunk and dynamic desirable. Actually, they rarely use trunk. They always require you to use dynamic desirable. Very, very important, dynamic desirable. I've seen it so many times. And I've had my students also, when they go to take the exam, they tell me that the DTP is used so much. Yeah. So that's pretty much the end of this class. And I'm going to give you some assignments here to do. And the first assignment is, let me just see this. Yes, the first assignment, you can start by this syntax checker. 11, please note that down. 3.3.11. Then syntax checker, you can do a packet trace on 3.3.12 to continue practicing 3.3.12. Then to configure trunks is 3.4.5. 3.4.5. So the other assignment can work for itself to practice as well. And the last one is 3.6.1. Remember, that's the last one. 3.6.1. 3.6.1 is the last one that you are going to work on. Yeah, 3.6.1. 3.6.1, you're going to configure VLANs, assign ports to the VLANs, configure setting trunking, and even dynamic trunking. So that's the end of this class, guys. I will require you to practice on those few assignments I have given you guys. Why am I saying that? I'm saying that because tomorrow we are going to talk about inter-VLAN routing. Today we have seen how to communicate, how devices within the same VLAN can communicate. So tomorrow we learn how devices in different VLANs can communicate, and that's what we call inter-VLAN routing. Communication between one VLAN and another VLAN. Communication between one VLAN and another VLAN. Otherwise, today we finish early at 2 minutes to 7 o'clock, and we meet tomorrow for our next